I don't know.
Yeah, no, I did it. I submitted it. It's okay, no, it's great. But you want to know what I did? Yeah. So, so you turn that one. It is 6, right? So 6 minus 6, but that one's going to be 0. And then I did all and then we're doing an integral at g of x minus b at 1. So that's you 6 minus 6 is 0. So you have to do all the integral. And so you just get b at x for the top one.
She
No,
prime 6 over 3, so it's 2. That makes sense.
All right, so you have about 15 seconds and then it'll close and we'll go through it. So if you haven't made a guess, go ahead and make a guess.
Fraction
You
decimal.
can do it, yeah. You're probably right.
What did you get for number 2?
Get it right.
It's 3 to 3, which is 27.
All right. So number 1, what did you guys think on number 1? What did you notice when you took the limit? What did you get at first? You tried direct substitution. What's the numerator? 0, and the denominator is 0 as well. So if you get 0 over 0, what do you have to do? L'Hopital's rule. What is the derivative of the numerator? What happens when you take a derivative of an integral?
You get it's g.
Yeah, so we just get g of x. So the derivative of the numerator is g of x. What's the derivative of the denominator? G prime. So it's really g at 1 divided by g prime. So the answer was 2. So D is the correct answer on that one. So that was a L'Hopital's rule, how they make it look, how they can take something that we're good at and make it look a little different.
When you do the integral,
Uh-huh.
like, would you just plug in x normally?
Yeah, so the rule is because, well, yeah, so when you're just doing the direct
Yeah.
substitution, yeah, if you just plug in 1 for x, and so the integral would go 1 to 1, and that's why it's 0. That's why initially it's 0.
So
Yeah.
how do we know that the top is 0 without being able to get the antiderivative of g? Because this would be the antiderivative of g of x minus 6, yes? The top?
No, you mean when we're just plugging in?
We were
taking
just
the
plugging
limit?
in to figure out the 0 over 0.
No, because if you're plugging in 1 for x, you're integrating something from 1 to 1. So
Oh,
it doesn't
I see.
matter what this is. If the lower bound equals the upper bound, that's why it's 0.
Yeah.
Okay, so then on number 2, this answer was C. You guys want to see this one? We do.
Is C?
I haven't looked at it, but that's what I have written down. Let's take a look. Okay, so they want us to find the x to the 6th term of this. So I would start with, it did say it was centered about 0, so we can use a Maclaurin if it's centered about 0. So I'd write out the e to the x series, which is 1 plus x squared over 2 factorial, x cubed over 3 factorial. And then I would do e to the 3x squared. So I'm going to do a substitution everywhere there's an x and substituting 3x squared. So 3x squared. I know I just need the x to the sixth term. Well, I'll keep going. So 3x squared over 2 factorial, 3x squared cubed over 3 factorial. Again, those parentheses are important. Then we have to divide everything by 2. So every one of these terms gets divided by 2, which is really just putting an extra 2 in the bottom. So the x to the sixth term would be right here. So that x to the sixth term, when we cube the 3, we have 27 x to the sixth over 3 factorial, which is 6 times 2. So 27 divided by that, let's see, 3 can go into here, what? 9 times. So 9, this is left with a 2. So 9x cubed, x to the sixth over 4. Is that right? Yep, and then the answer is C. Not too bad. So just more of that Maclaurin, plugging stuff in. Okay, so then a couple of things. The next thing I want you to look at, so while you're in Canvas, go to this week's module. We're going to cover 8.4 today. 8.4 is ratio test. It is our final test of convergence and divergence we're going to learn today. But then you have this third try group request. So if you open this, you don't have to fill it out necessarily right now. Wait, what is it? You have a Band-Aid on your thumb. Something. Okay. I don't remember my passcode. Well, it'll work for you guys, but you can fill that out now. You can fill it out tonight. Keep in mind, it is just a request. So if you look at it, I'm trying to remember what my questions were. I think you have to first say your name. I think I asked you what class period, is that right? Somebody have it up, so I know. So you're requesting a group within the class. I would like to have our seating arrangement be like in groups. So tomorrow I'm gonna have our classroom arrangement be a little bit different, especially as we start to study for the AP test. There needs to be a lot more interaction between you guys and less of just me talking and more of you guys just working problems and kind of struggling through them for us to make progress. So I want you to choose a group. I want you to choose people who are in this class. If you're unsure, you know, if one of your friends is here, you can ask me after class and let me know that. But I want you to have a physical group that you meet with, and then you'll also have some group stuff outside of class. Okay. So just if you'll fill it out at least by 3 o'clock or 2:30 today, so that after school today I can put together the groups, and then we'll have a seating chart where you're going to be sitting by your group, and you can also do other stuff. Any questions about that? Now again, it's a request. If like the 4 top students in the class all ask to be together, I'm probably not gonna make all 4 of you guys be together. I might spread you guys out. So I might have reasons for not honoring your request, but I will try to accommodate what you guys think.
If you don't care,
And if you don't care, please, you can just put that you don't care, and that would be great. That way I know I can put you with whoever. So yeah, yep. Okay, and then the next thing I want you to look at is the disclosure I just handed out. So sorry, let me. The disclosure for this try will be a little bit different, only because we have, there won't be a final, first off. That's if you guys have taken your last final. Sorry, hopefully it comes up here, but you have a hard copy. The percentages are slightly different. So instead of 20% assignments, it's going to be 30%. The project that will happen after the AP test, so we'll talk more about that later, but you'll have a project after the AP test that will go in that category. A couple of differences, let's see, only 1 assignment, no assignments will be dropped. So the reason for this is once we start reviewing, you're going to have like an assignment for the week. Instead of a daily assignment, you're going to have a packet for the entire week. So if I dropped 2, that would be huge because you, instead of daily, you just have weekly. So there will be a fewer number of assignments. So instead of dropping them, there will be a late pass. You can get 1 late pass. if this works. I don't know why it's not working. I'll figure it out, but let's see. It says, okay, so about halfway through that paragraph, so no assignment scores will be dropped third trimester. Instead, each student will receive one late pass. This will allow for one assignment to be turned in late without penalty. If you turn in all of your assignments in on time, then the late pass can count as 10 points extra credit in this category. So if you don't need a late pass because you turned everything in on time, you get a little bit of extra credit. To indicate which assignment you would like to apply your late pass to, or indicate that you would like the extra credit applied to the extra credit survey, extra credit, you will complete this survey, which once it starts working on Canvas, there will be a link that you can click on, and then that's where you'll put it in. I would recommend not doing that until the end of the try. I don't want to have to keep changing it for you, like, oh, I missed the first one, apply my late pass to that one, and then 2 weeks later you miss another assignment that's worth more points, and you're like, wait, switch it to that one. So better to just wait till the end of the try. If you have multiple ones that are late, you can use it towards that one. I will tell you again, because once we start reviewing for the AP test, those weekly review packets are going to be worth a lot of points. So you really should try, if you like, try not to use it right away. So try like for this next 3 weeks as we're doing our regular assignments, hopefully you won't need it. Okay. Did it work for anybody else? Was it just me that it was doing that spinning thing for the document, the disclosure? Is it open for anybody?
It's not on.
It's not even on there? Okay, so I'll have to figure out what I did there. AP test is May 5th, so nothing's really different there. Oh, there will be a practice exam. This is one good thing about the whole Friday thing. It used to be that I'd have to make you guys come in on a Saturday to do the practice exam. I'll pick a Friday. I tentatively think that that Friday is going to be April 23rd, which would be a Friday. I'm sure I'm going to have to check with other AP teachers. We're all going to have this same wonderful idea to make you guys come in on a Friday. But then you'll sit the full exam. Each year AP releases a practice test for us to use for this purpose. So these are questions that we haven't used at any other point. And then you'll be able to get a practice a score. We'll score it 1 to 5. You can see where you are. And it still leaves us with 2 weeks to finish getting ready for the test. Okay, we will have our Unit 8 test this Friday. So Unit 8 is over series. So we're almost done with series. We just have 2 new sections. Unit 8 test this week, then we have 2 weeks on Unit 9, and then we start reviewing. So I unlocked the final from last week. So I want to talk about it tomorrow, but I want to give you guys tonight to kind of look at it now that it's unlocked. You can look at your mistakes and look it over first. So if you'll look over your final sometime tonight, not necessarily, not right now, but look it over, see which ones you missed, see which ones you're like, oh yeah, I know what my mistake was, and which ones you want to talk about. We can talk about some of those tomorrow. All right, let's go ahead and look at Unit 8, Section 8.4. If you guys have any questions about what to expect this try, the disclosure, or anything else, if you think of anything, we can talk about it tomorrow. Okay, the ratio test is very similar to the geometric series test. The geometric series, if we have a geometric series, if you had a geometric series where it wasn't obvious what the ratio is, heck here, I'm gonna, let's say I gave you one that was like 16. If I said the first term was 16 and then the next term, oh, I want it to be a good one. Okay. Wait a second. Yeah, okay. Okay, so let's say you see a series like this, and it's not immediately obvious what the ratio is. Maybe it is to you, but let's say you see a series and you can't quite tell what it's repeatedly being multiplied by. What's one method you could use to find the ratio, or to see if there is a common ratio between a list of terms? Yeah, Amelia. Sure. What do you mean by that?
Like if each of them are divided, like I don't know. Like, I'm thinking like each of them is like able to be divided by like 4.
Okay.
Like, I don't know.
I think, but I wouldn't necessarily go factoring. That might work, but that's not the method I had in mind. I heard somebody say that they recognized it. What did you think it was?
Looks like 3 halves.
Okay, what made you think that it was that?
Because I just looked at, dividing one term by the next,
One term by the next
or
or the previous?
either, I don't know.
The previous,
The
right?
previous,
So
yeah.
since a common ratio is we're asking ourselves, like what did we multiply by to go that way? If you're trying to work backwards, you can pick any term and divide it by the previous term. So if you take a term and you divide it by the previous term and you reduce that, that reduces to 3 halves. If I did it with any other pair, so any pair, if you want to figure out what that ratio is, the ratio is a term divided by the previous term. Well, 16 divided by that is 3 halves. Now, again, it works with any pair. So if you take any pair, if you take a number and you divide it by the previous number, you're going to get the ratio. Okay. So this idea is if you take the next term and you divide it by the previous term, that's going to give us our ratio. And that works for a geometric series, right? That's if it's repeatedly multiplied by a number. Well, this ratio, the way we get that ratio is this kind of the foundation for ratio tests. Maybe it's not geometric, but there is some common ratio between the terms. So the common ratio, we're just going to be taking the limit of that ratio, which means the next term, to indicate the next term, we do n plus 1 divided by the previous term. The rule is identical to geometric series. If that ratio is less than 1, then it's going to converge just like a geometric series would. If that ratio is bigger than 1, then it's going to diverge. Now, infinity is bigger than 1, so I think of that. If it's infinity, it's going to diverge. The ratio test, just like the geometric test, is inconclusive if that ratio is equal to 1. Okay, so it's pretty easy to memorize because it's the same idea. It's just, the ratio may not be a constant. The ratio may be something different. Factorial, for instance, we've said that factorial is not a geometric series. So it's not geometric, but there might be a common ratio between these terms. So if I'm going to apply ratio test here, the idea is I need the a n plus 1 term divided by the a sub n. Now, there are absolute value bars in front of it, so we get to drop. That would just mean like if it was alternating, we wouldn't consider the alternating piece, and then we're taking the limit as n goes to infinity. So this is like our goal. So first I'm going to worry about getting all the stuff on the inside. So I need the a sub n plus 1 term. That just means currently right now, this is the a sub n term. So I'm just replacing n with n plus 1. So everywhere there's an n, I'm going to write an n plus 1. So the n plus 1 term is n plus 1 in parentheses factorial over 3 to the n plus 1. Okay, so again, all I did was replace the n with an n plus 1. Okay, so that's the n plus 1 term. Then I would be dividing it by the a sub n term, but if I'm dividing it by the a sub n term, the a sub n term is the original one, the one that was listed. There's the a sub n. Dividing by a fraction is the same as multiplying by the reciprocal, so I'm really just multiplying by that. Doesn't ever ring. Hello? Nope, wrong one. Okay. Okay, wrong Miss Brown. Okay, so we have the ratio. Now we need to simplify this. So as we try to simplify this, a couple of things. We need to remember how to like simplify. Let's deal with the factorial first. If we have n plus 1 factorial divided by n factorial, what do you guys think that reduces to? I'm going to remind us for a quick second. If we have n plus 1 factorial over n factorial, n plus 1, because n plus 1 factorial means n plus 1 times n minus 1, and n factorial n times the previous times all of the previous. So when you reduce factorial, n plus 1 factorial over n factorial just gives us n plus 1, no more factorial. So I know that this gives us an n plus 1 on top. So that was this and this. Now let's think about how we can reduce the 3 to the n over 3 to the n plus 1. So we've got 3 to the n, we're trying to divide it by 3 to the n plus 1. Well, 3 to the n plus 1 is equivalent to 3 to the n times 3. So that idea that if you have a sum, you can break it up into the product of each thing to each power. So the 3 to the n cancel each other out. So it really just reduces to a 1/3. Does that make sense? So the only thing we have left on the bottom is a 3. So we've reduced the next term divided by the previous term. We still have to take the limit, so I'm gonna write the limit as n goes to infinity. As n goes to infinity, what does that limit equal? Infinity. And infinity is bigger than 1, so therefore it diverges. So this goes to infinity, so therefore this series diverges by ratio test. Because that's bigger than 1. Okay, so the thing that takes a little bit of getting used to is this simplifying. So let's practice again. So our rule is we have to do the n plus 1 term. So the n plus 1 term, everywhere there's an n, we're rewriting an n plus 1. So the numerator is 3 to the n plus 1 over 4 to the n plus 1 times quantity n plus 1 squared. And we'll go back and we can simplify. Okay, so the n plus 1, you're just making that substitution. We're dividing by the original term. So really, I'm just multiplying by the reciprocal. So 4 to the n times n squared is now on top over 3 to the n plus 1. Okay. Up here, the n plus 1, that's really 3 to the n plus 2. So this is 3 to the n plus 2. But if I do that same rule that I did on the other one, I could rewrite that as 3 to the n times 3 squared. This 3 to the n plus 1 on the bottom is really 3 to the n times 3. Okay, so this 3 to the n and this 3 to the n cancel each other out. I also could cancel out a 3. So when I'm thinking about what this simplifies to, I know that there's a 3 on top. Okay, let's look at the 4s. So let's look, I have a 4 to the n and a 4 to the n plus 1. What is that going to reduce to? 1/4. It's going to have a 4 in the denominator. Again, because this is 4 to the n times 4, the 4 to the n's are going to cancel, so I'll have a 4 in the denominator. I still have the n squared on top, and I still have the n plus 1 squared in the denominator. Now we take the limit. So now we take the limit as n goes to infinity. So you do all that simplifying, and then you take the limit as n goes to infinity. As n goes to infinity.
Sorry, do not simplify the
Did I?
n.
We don't need to because we're taking the limit to infinity. So I don't have to like factor it because what happens is n goes to infinity. I cannot just cross them out. I can't just like cross them out, but the limit as n goes to infinity. As it goes to infinity, they cancel each other out. So we get 3/4. We okay with that? That is less than 1. So what's our conclusion? Yeah, so it's going to converge by ratio test. Because that ratio did come out to give us something less than 1. So they take a little getting used to in terms of the simplifying, but once you get the hang of it, it's really not a bad test. Okay, let's look at number 3. What stands out to me is it's an alternating test. It's an alternating series. But when I do ratio test, I have the absolute value bars. So I'm just going to ignore the negative 1 because I'm just going to work with the other part because the alternating piece doesn't matter. So the n plus 1 term, I'm just replacing n with n plus 1. If I replace n with n plus 1, the denominator is just n, right? Then I multiply by the reciprocal of the original. Again, I'm leaving off the negative 1 piece because I know it's supposed to be the absolute value. And I'm taking the limit as n goes to infinity. What is that limit? This one we can't reduce in the same way we have the others. What is that limit as n goes to infinity? 1. You guys see that that's equal to 1? Both of them have a square root and an n on top. The minus 1 and plus 1 pretty much go away. What does that tell us? Yeah. So this tells us that the ratio test is inconclusive. So we have to think, okay, well, we have other tests. Alternating series. If it's alternating, I would try alternating series test first anyway. So alternating series test, this is an alternating series. Alternating series. There are 3 things that have to happen. What's the second thing? Good. The limit and notation, I saw this on, I can't remember if it was your test or your quiz, but your limit as n goes to infinity, you have to say of a sub n. So if you want to like keep it as simple as possible, that's meaning what's the limit? A sub n is this. What's the limit of that as n goes to infinity? 0, because it's bottom heavy. So it is 0. And then the third thing we have to state, non-increasing. It is non-increasing, these terms. If we wrote them out, we could see that they are decreasing. So based on these three, we can say it converges by alternating series test. Okay. I debate on even dealing with number 4 because it's showing us a double factorial. You have one of these on your homework. You're never going to see one of these, but we'll look at it just for practice. All a double factorial is saying is instead of doing like 5 times 4 times 3 times 2 times 1, you would either do just all odd or all even. So you would do 5 times 3 times 1. So you would do odd, or you would do like 8 times 6 times 4 times 2. So you just count by 2s instead of counting by 1. That's what the double factorial is. So as long as you know what to start with. So notice if the 2n plus 1 is starting at 2n plus 1, and then it's dropping by 2. So instead of minusing 1, you minus 2 to get the next number to multiply by, because even or odd numbers are 2 units apart. So that's the only difference. But let's practice just so we can see it. So they're writing that out. They're showing us the nth term. We need the n plus 1 term. So the n plus 1 term, we're swapping out the n for n plus 1. So I'm going to have 2 times n plus 1. I'm going to write it out the long way. So this is the numerator where n becomes n plus 1, and just swapping out n for n plus 1. Same thing in the denominator. So I have 3 to the n plus 1 times 2 times n plus 1 minus 1 times n plus 1 factorial. So again, every one of these n's, I just swapped out for an n plus 1. Okay, I am going to multiply by the reciprocal of the original, but I'm going to simplify this just a little first. If I distribute this 2, this is really 2n plus 2. And then I have to add 1. So the numerator, I get 2n plus 3 double factorial. In the denominator, I'm going to write that 3 to the n plus 1 is 3 to the n times 3. Here I could distribute that 2. That'd be a 2n plus 2, but then I'm minusing 1. So I'd have a 2n plus 1, and then n plus 1 factorial. So there's my n plus 1 term simplified. I multiply it by the reciprocal of the original. So the original, now I have the 3 to the n on top, 2n minus 1, n factorial, and the denominator, 2n plus 1 double factorial. So if we reduce this, let me try looking at this right. Yeah, okay. If we reduce, let's look at just reducing this 2 to the double factorial pieces. Those 2 are going to reduce to give us, let's see, it'd be 2n plus 3 factorial, and then 2 prior would be the 2n plus 1 factorial, or 2n plus 1. So all of those are going to cancel out. So the numerator, let's see, this term cancels out with all of that. So the factorial will go away. We'll just be left with the 2n plus 3. Let's go to the 3 n's. So the 3 to the n and this 3 to the n cancel each other out. Let's do the other factorial. If it's just n terms, we don't really reduce, because that's going to, they'll reduce as we go to infinity. So now I'm going to look at the n factorial over n plus 1 factorial. So there we're going to end up with what, n plus 1 in the denominator. So the factorial and the n cancel out. Okay, trying to make sure I've got all my pieces. Okay, so what I'm left with, I'm taking the limit as n goes to infinity. What do we have left on top? On top, I see a 2n plus 3, and I see a 2n minus 1. In the denominator, what we have left is just the 2n plus 1 and the n plus 1. Oh, and the 3. Thank you. I almost lost my 3. And the 3. If we take the limit as n goes to infinity, we can use our degrees. What's the leading term of the numerator? We multiplied that out, which we don't want to do, but just the first term. What's the first term? 4n squared. I'm going to go ahead and write this up. So the numerator would be 4n squared. If we multiplied out the denominator, what's the leading term? 6n squared. So really, we're taking the limit as n goes to infinity of this, which is 4/6 or 2/3. 2/3 is less than 1, so our conclusion is it converges by ratio test. Okay, so again, you'll never see a double factorial of 1 on your homework. It's just kind of like you've seen it, but they won't ask you that on the test. Okay, so then your book, I think, then shows you the rest of this is just handling all of our, oh, good. It gives you on the next page this little table. Here's a summary of all of our tests. So you'll do a few that are just ratio tests, and then the rest of your assignment is, you can use going forward any test you want. In general, I start with the easiest test. If I can prove something diverges by the nth term test, I would use that one definitely first. I think it's going to diverge, I would choose that. Geometric series test, we all know we can use that if we can identify the ratio. P series, alternating series. Integral test is probably one of the last ones that I use. It would only be if I could obviously see that maybe a U sub would work. We have ratio test, and then the two that we learned a couple weeks ago, the direct comparison and limit comparison. Okay, so if you want, like, this is kind of like your cheat sheet to keep coming back to. So let's look at these examples. What do you guys think? What test could we use here? Nth term. Yeah, so I always look for that first. So nth term, the work that you have to show, the minimum amount, you have to at least show that the limit as n goes to infinity. If you don't even want to write that out, you have to say a sub n. What is the limit of that series as n goes to infinity? Which is not equal to 0, so it diverges by nth term test. Okay. My thought when I see this one is that negative exponent, I'm going to rewrite that in the denominator. If I rewrote that, so this is the same as n squared over e to the n cubed. Thoughts? Often more than one test can be used, but one test stands out to me here. One I don't normally like to use, but this one's just set up so perfect. You guys see how we could do the integral? It looks pretty terrible, but I see the numerator as being like the u sub of the denominator, that inside piece. So I'm going to use integral test. So I'm going to integrate x squared over e to the x cubed. I'm going to integrate from 1 to infinity, or I'd be taking the limit as b goes to infinity. So I'm integrating that. Again, the reason the integral test stands out to me is because if I let u equal x cubed, if u is x cubed, what's du? 3x squared. So that numerator is the derivative of that inside piece. So I put a 3 on the inside and I take a 1/3 out in front. So when I rewrite this, I have 1/3 integral of 1 over e to the u du. I would rewrite that 1 over e to the u. I'm going to rewrite that as e to the negative u. What's the antiderivative of e to the negative u? Good. So a negative comes out e to the negative u, or I'm going to say negative 1/3 1 over e to the u. Coming back, way back over here. So I'm taking the limit as well. I'll leave off the limit for a second. So I have that. I need to replace my u. So I have negative 1/3 e to the, what was it, x cubed. I need to evaluate from 1 to b. I'm going to leave the negative 1/3 in front, and I have 1 over e to the b cubed minus 1 over 1 to the 1. And then I take the limit as b goes to infinity. I'm going to focus on the piece that has the b. If b goes to infinity, I have e to infinity, which would be a big number. What's 1 divided by the giant number? 0. So this piece here approaches 0. So really, it's just negative 1/3 times a negative 1, so we get 1/3. That means if the integral converges, then this series converges by integral test. So you can see why it's my least favorite one. But when it is set up to do a u sub, like that, I would do it. So I only do that when it's pretty obvious that it like a U sub could end up working. Okay, what do you think about 7? Geometric. Do you guys see this as geometric? If anytime you have like a quantity to the end, then that quantity that's being raised to the end, especially if everything on the inside is a number, E is a number, then that's our ratio. So our ratio is E over 3. Which, by the way, if you did ratio test, if you did the n plus 1 term divided by the nth term, you would end up getting E. So your ratio would be that. So you could go the long way, but we don't have to. What is E approximately? 2.7. So this is less than 1. The denominator is bigger than the numerator. So our conclusion is it converges by geometric series test. So some of the tests are super fast and some of them take a little bit more. That one was a fast one. Okay. What do you think about number 8? What series, what's your hunch? Do you think it's going to converge or diverge? I've heard both. What if I compare it to a series that's really close to it? What series is really probably going to behave the same way? 1 over n. You guys agree those are probably going to behave the same way? Timesing by 4, adding 5 to go to infinity isn't going to make a difference. What do we know about this series? This one converges. You want to memorize this one. This one converges. Well, I'll call it harmonic first. So this is a harmonic series. Harmonic, so therefore it converges. Or you could, oh, sorry, diverges. Thank you. Diverges. Or you could use P-series test to prove that it diverges. P-series is if it's to a power of 1 or less than 1, it's going to diverge. Okay, so if that diverges, I know I'm doing some type of comparison test. You could do direct comparison or limit comparison. Yeah.
You just use nth term test to say the limit's 1/4, not 0.
As n goes to infinity, it would be 0. Right? 'Cause it's bottom heavy. Yeah. Okay, so I like limit comparison, so I don't have to worry about putting my inequality in there. I'm going to go ahead and just do limit comparison. You take one of them, you divide by the second one, which is multiplying by the reciprocal, and then you take the limit as n goes to infinity. Now, since there's an n over 4n, this one does go to 1/4, which is a finite number. Our limit comparison test just said as long as you get a finite number out, as long as you get a number that's not infinity, then both series do the same thing. So both series will converge or diverge. But since we proved the one we're comparing it to diverges, we can prove this one diverges by limit comparison test. Okay. What's the first thing you notice about the number 9? Alternating. If I see an alternating series, I would try alternating series test before anything else. Alternating series test. So on 9, the series alternates, an alternating series. What else? Good. And your notation, you have to say the limit is n goes to infinity of a sub n. You make sure you write that a sub n, so you left that off on your test. Is 0. It is bottom heavy, so it is 0. And then the terms are non-increasing. So therefore, this series converges by alternating series test. Remember, alternating series test can only prove convergence. You could never make a statement that a series diverges by alternating series test. Okay. Number 10, when they write it out, we have to kind of identify the pattern ourselves. I would just do the numerator first and deal with the denominator. What does the numerator look like? N factorial. They wrote it out nicely for us. So when I see this, I go, okay, well, this appears to be n factorial on top. What does the denominator appear to be? 10 to the n. So this looks like the sum of that series, where n is going from 1 to infinity. As a general rule, if I have an n factorial, I almost always do ratio test. Okay, so factorial makes me think I'm going to do ratio test, unless I can prove divergence by nth term test. If the factorial is in the denominator, then sure, I could just say it diverges by nth term test. In this case, I'm going to do ratio, which means I'm replacing n with n plus 1. So same thing in the denominator, I'm replacing n with n plus 1, and then I'm multiplying by the reciprocal of the original. So 10 to the n over n factorial. I'm gonna simplify and then take the limit. Okay, n plus 1 factorial divided by n factorial reduces to what? N plus 1, very good. So the factorial goes away, that goes away. Remember, 10 to the n plus 1 is 10 to the n times 10 to the first. So the 10 to the n cancels out. So on top, we're just left with an n plus 1. On bottom, we're just left with a 10. And then we're taking the limit as n goes to infinity. What do we get? Infinity, which is greater than 1. So just like geometric series, if the ratio is bigger than 1, our conclusion is it diverges. It's going to diverge by ratio test. Oh, shoot, I was saying this at the very beginning and I didn't even listen to what I was saying. What other test could I have done that would have been way faster? An external test. I was kept talking and talking but didn't actually look at it to see. So I could have, so that's one option. Or a lot faster, I could have just taken the limit as n goes to infinity of this term. What increases faster, factorial or exponential? Factorial. So this does equal infinity. So I could have said it diverges by nth term test. Okay. So, often there is more than one test that would work. There was an easy way that I overlooked at first, and then the harder way, but both will give us the same conclusion. All right. Each core assignment. Okay, have questions 1 through 21. They want you to use ratio tests for questions 1 through 7. So even if you think a different test would work, try ratio tests to get the practice on those 7. After that, you get to choose any test you want for 8 through 17. So really, you're just practicing all of these tests. Which tests did you apply? And then there are a couple of these more involved questions where you go through all of the previous stuff. So, all right. So again, the disclosure, I'll put an assignment on Canvas so you can just sign the page and then take a picture. You'll just upload the signed page to turn that in. Fill out that survey for your seating chart if you wouldn't mind doing that by 2:30 at least, maybe even lunchtime, so I can put the seating chart together for tomorrow. If you have additional comments where it asks for who you want to sit by, if you need to be I need to sit towards the front or anything else, you're welcome to kind of fill it in there. And that's it. So I'll let you guys work. Yeah.
Sorry, number 1.
Yeah.
How do I handle simplifying once I have n plus 1 cubed over n cubed?
Yeah. So on number 1, my initial thought is I would normally just use ratio test, or not ratio, and term test,
Yeah.
but they're making us use the other. So let's do number 1 using ratio test just to prove it. So I would do the n plus 1 term over n plus 1 cubed times n cubed over n factorial. I would reduce the factorial, so the factorial and the n plus 1 goes. So I'm left with an n plus 1 times n to the third over n plus 1 cubed. When I'm taking the limit though, as n goes to infinity,
Okay.
we really just need to worry about the leading term. So the leading term, if I multiply the numerator together, the leading term is n to the 4th. And the leading term in the denominator would be n cubed. So I'm taking the limit as n goes to infinity. One common mistake I see on a test, which is important in terms of just notation, students will do it right, but they don't write limit. If you say that limit equals n to the 4th over n cubed, that's an incorrect statement. You have to write the limit notation in front. Now the limit as n goes to infinity, that is infinity, which is not equal to 0. So therefore, well, wait, no, I'm doing ratio test. Ratio test is greater than 1, so it diverges by ratio test. But one of the common mistakes I see on the test where students do everything right, they'll give me this statement. They'll tell me the limit. They'll say the limit reduces to this and it equals infinity. But this is now incorrect. You guys see how this would be marked wrong without this limit notation in front here. Yeah. All right.
Hey, do you have any Band-Aids?
I do. Okay. All right. Maggie, I got your answer, so that's great. Question. So if we do groups, if there's somebody in this class period who you would feel comfortable with, so that we could just have like, you know, they could join the Zoom meeting as well, so that you can still communicate with your group, so that during this work time or during the time when you guys get time to work together. So just if you want to, when you fill out your survey, if there are students that you feel comfortable with working with in this class, just do the same thing and I'll just assign you to their group so that you can get that interaction with your group during the work time. Great. Thanks, Maggie.